Hello everyone, welcome back to IntroVEX, your robotics guide to excellence. In this episode, we'll be talking about something new and that is more commonly used in VEX V5 but can also be used in VEX IQ, and which is connecting pneumatics. This is a really interesting topic that I think many of the new income VEX V5 competitors will be kind of confusing about, and this is also something that actually made me think about for a long time and try to figure things out. This time we'll talk about the theory behind how the air flows in the system and introduce the individual pieces that you may use to connect air. And next time we'll talk about where these pieces can be placed on the robot. Okay, so why do we use pneumatics? The first question that you might pop up in your mind is that why even we bother using pneumatics on the robot when we already have motors and we can use more motors in VEX V5 than IQ? But even though we got 88 watts of motor power to use, meaning that at least 8 motors can be used to power mechanisms and subsystems, there are still some small angle motions that are not used consistently, and it will waste a lot of motors if we use motors for those. And I'll be introducing the following situations that is best to use pneumatics. First, it is when there is a repetitive motion back and forth and up and down. It is not a rotational motion, it only goes up and down. For example, there is a hook that you might put up and then put down to grab something on the field. And second of all, it is not used consistently. You don't, for example, drive your robot chassis with motors, right? This is because that it is used for navigating through the field. But if it's not used consistently, for example, it's only dropped when, for example, the opponent is in front of you, there are certain circumstances for you to use it, then it's not used consistently. Third of all, there is no constant rotational motion. The most common places where the motor are used is either the intake, where it spins a roller that gets blocks up, and the chassis, where the wheel has to rotate to move the robot. And fourth, it's when the range of motion is less than 180 degrees. This is best for using pneumatic cylinders as it can provide you motion throughout these angles. But if you have motions greater than that, it might be a little difficult to use pneumatic cylinders, or else you need additional structural design to help you achieve that. Example, let's take a look at our second generation pushback season robot trailer video, and let's look at this clip. So you can see that let's do it again. So you can see that there is this structure that dropped down when it's going under the longo. This is where we used a pneumatic cylinder for the system. And why? This is because that the motion is only 90 degrees, around 90 degrees, and it's only used under certain circumstances when we have to go under the longo, and that it's not a constant rotational moment. So we used a pneumatic cylinder for putting it up, and for retracting we only used rubber bands and gravity, so which means that it is a single acting system right here. Alright, so let's start with the most obvious component that you see on the robot that is actually functioning the up and down or back and forth motion, which is the pneumatic cylinders. Yes, and there are actually 3 lengths of the cylinder. The first one on the top here, this is the 25 millimeter stroke cylinder. The middle one is a 50 millimeter stroke, and the last one is a 75 millimeter stroke. So all these are able to extend and retract, and as you can see, there are 2 holes on each sides of the cylinder, and these are for connecting the fittings and then connecting the tubings. So since there are these strokes that goes back and forth, it is powered by air, because this is actually a piston. So imagine if the air goes from the back, it'll push the stroke forward, right? And if the air goes in from the back, it will then push the piston back. So this is how the pneumatic cylinders work. So connecting a fitting would be like this. You connect a fitting on the hull and then you connect tubing to it. Since there are two holes on each side of this cylinder, you typically use air for both extension and retraction, but you can also only put one fitting on it, and then the opposite motion will be conducted through maybe like rubber bands, or it will just not retract. So take an example of this 75mm stroke pneumatic cylinder. The straight fitting is only put on this hole. This is the retraction hole, which means that if you want to extend it, you need external forces, maybe like rubber bands and stuff, and there will only be air used to retract this this cylinder. Yeah, and this can be used on many different kind of scenarios depending on what your function is. Now, it's time to control the cylinders with our VEX V5 brain. And how do we do that? We use the solenoids. The solenoids have one end connected to the brain with cables, which the cable is shown on the right, and another end is connected to the corresponding extend and retraction hole on the cylinder. So first, there are two ports here. There is port A and port B, and one on the left, one on the right. This is where the air will flow through, and fittings will be connected here. There are this P port here on the right, and there's also another P port, and these are for connecting the solenoids together by like connecting the whole system together. For example, if you have two solenoids, you can connect one P port to another P port on the other solenoid, so you don't have to use a T fitting to split up the air. And this is very useful. This is the newer version of the solenoid, and I think that is one of the good things about it. And for the R port, you do not have to place anything here. Don't put some screws or whatever. No, this port is for the air to flow out when it's switching between A and B. So if you fill it out, I don't know what will happen. It probably explode, I don't know. And another P port. And what is down here, you can see there are two holes. These are for screws. So just put your screws here. Don't put it anywhere else. You do have to be careful on connecting the ports because it will change the initial state of the pneumatics. So what you do when you figure that, oh, I should let it extend at first, or I should let it retract at first, but it's doing the opposite. Now you have three different options that you could do to change these. First, you can switch the solenoid wire position. As you can see on the previous slides, the solenoid currently is connected by a green and white wire on port B and a red and black wire on port A. You can simply switch up these two by connecting the red and black one on port B and vice versa, and you'll achieve the opposite initial state. The second method is to switch the tubing of the two holes on the cylinder. There is the extension and retraction hole, right? You can switch up those tubings connected to them, and it'll work as well. But you can only choose one, or else like it'll be the same result if you do two. And the third one is to switch the tubings of port A and port B on the solenoid. These three are all valid, so you just have to choose which one you want to use. Typically choose the one that is easiest to change. Sometimes the wires or tubings are actually hidden inside the robot and it's difficult to reach. Moving on to the next component, and they are the fittings. The fittings are typically for allowing air to flow through between all those air tanks and pneumatic cylinders. And we'll introduce it one by one, but there are four typical fittings that you will see the most common. Alright, starting with the first one here. We got the elbow fitting, this one. It's a 90-degree angle, as you can see. Okay, next is this shut-off valve. This is for helping you pump air easier at somewhere further from the air tank. So one side, the air flows it's connected to the air tank, and the second side it is left blank for you to attach tubing from your pump and pump in if needed. And when this beam here is vertical, perpendicular to this line where the air flows through, it blocks the air, so the air don't flow out from the air tank. And when it is parallel to this line of where the air flows, you can pump air from the outside to the inside, and if you don't pump it and simply open the switch, then the air will flow out. All of the air will flow out. Yes. And this is extremely useful when you need pumping. So take a look at this air tank right here. Typically, it was always attached with this golden stuff that you can directly pump your air in. However, this means that you have to be able to reach your air tank at all times for you to pump easily. But sometimes if your air tank is like at the bottom of your robot, you can remove this golden thing into a male fitting and then connect the tubing to the shut-off valve, and you can pump anywhere that you like. So it'll be a lot better. Moving on, this is the straight male fitting. This is the most common fitting that you'll use. Okay, so next is the T fitting. It's a T shape. There are 3 holes. So this is used to split air from one entry and exit with 2 exits. So if you, for example, have one solenoid that is controlling 2 pneumatic cylinders, you will need a T fitting so you can split up the air. The air tank is where the air gets pumped into and storing it for the usage during the match, and then you can use up to 2 air tanks and pump up to 100 psi in VEX V5. Each air tank powers a loop of a system of air, so you can connect, but you can also connect 2 air tanks together, so you can have a larger amount of air usage in a single system. Next is the tubing. These are simply the pipe that you're going to use to connect different components together, and the air flows between because there are hollow spaces inside the tubing. So now let's see how the pneumatic system is connected from the air tank to the final pneumatic cylinder. You first start up with pumping, right? So there will be a shut-off valve right here that is used for pumping air, and then we'll have to store the air into the air tank, and then we have to use tubings to connect the air from the air tank to the solenoids, which control the extension and retraction of the pneumatic cylinder. And then we have the pneumatic cylinders that actually functions to help the structure extend and retract. Okay, so with these individual components out, then we have to connect these fittings so that we can actually connect tubing onto it. So we connected 1, 2, 3, 4, 5, 6, 7, 8 straight male fittings onto these. There are 4 on the solenoids, 2 on the air tank, and 2 on the pneumatic cylinders. And now we move on to connecting the system with tubings. So these gray lines are tubings. So first, starting from the shut-off valve, that simulate how the air will flow. The air pumps into the shut-off valve, and then we close the switch, and then there will be air flowing into the air tank, and then the air tank air will flow into the solenoid, and then the air will be directed into 2 ports of the cylinder. One thing that you have to keep in mind is to always plug the fitting where the air is not needed to direct it to anywhere else. If you have any questions about different configurations, you can ask me under the comment section, and I can maybe create another video about all those variations of a pneumatic system so you could understand more about it. And that's it for connecting the pneumatic systems. And next time we'll talk about how and where you should best place your cylinders, your air tanks, solenoids, and many things onto your robot. So stay tuned. And this is IntroVEX, your robotics guide to excellence. See you next time. Bye bye.